So we'll be attempting the second question, which is the chest is accidentally dropped during use. Determine whether you can safely withstand a compression load. Apply 100 Newton downward force on the very top. So we have to perform a static analysis of this. So what I will do is to go to SolidWorks and click on my simulation. So once I click on my simulation, you see my simulation window is open. I click on simulation. I'll create a static study. Click on that static study. Then I come to, I've already applied material. Remember, we are using ABS plastic. So what are my fixture? Where do I want to fix? Where I'm fixing actually the bottom. Fixing the bottom. So that's my fixture. My load, where is my load? My load is actually at the top here. So I'm applying my load of 100 Newton. So I apply the load. So what is left now is to run my analysis. Mesh and run and see how this will behave under the load, under a particular load of 100 Newton. So now if you look at, so you may be wondering, where is the area of where we have more stress? So the area where you have more stress is the region that is colored red from your color palette here, telling you that this is the area with more stress, and that's where your maximum von Mises stress, you get your maximum von Mises stress. Now with this value, now how then do you know if this is safe, this structure is safe or not? Now first of all, let's convert this value to real numbers so that you understand. Let's do a bit of basic mathematics, should I call it basic mathematics? So we have 4.234 exponential 5, which means times 10 raised to the power of 5. So if you convert this to real value, we are moving this 1, 2, 3, let's say 4, 5. This means this is now 4, 2, 3, 4, 0, 0. I call it Newton per meter square. This is around 423,400 Pascal. So with this value now, for you to know your actual von Mises stress, you are comparing this value to your yield strength. But if you go and check what is the yield strength of ABS, so let's check our material that we apply, the ABS material. ABS doesn't have a yield strength on our SolidWorks material, so but it has a tensile strength. So since we don't have a yield strength, we can compare this with our tensile strength, and our tensile strength in this case is around This this is 1, 2, 3. This around 30 million, 30 million Pascal, or you can say 30 megapascal. You understand? 30 megapascal, compare 30 megapascal to 423,400 Pascal. 30 megapascal is higher than this. So by that mere comparison, you can see that this is safe. So the comparison is that you cannot have your tensile strength anytime that your material strength is higher than your von Mises. That means your that particular object is safe. Or you can say when the von Mises is lower than the material stress, that object is particularly safe. So from this scenario, you can see that our pawn is safe because our maximum von Mises is lower than our material yield strength. So I don't know if that makes sense. So another thing is that if you don't see your material yield strength, you can always go and use your tensile strength to compare it. For plastic, you necessarily will not see the yield strength of plastic because it varies. So I hope I've been able to answer this question.